Welcome to this video on how good is Dr. H at free throws. It's about randomness and probability. By the end of this video, you should be able to interpret probability as a long-run relative frequency. So, in today's episode, Dr. H thinks she is pretty good at shooting free throws. How many free throws would you like to see me shoot before you could be confident in guessing my free throw percentage? We'll watch me throw some free throws, and when you're confident and make a guess, we'll try that. So let's take a look at this applet. Thankfully, you're not going to have to actually watch me throw some free throws. That would be painful. So we're going to keep track of my shots on our piece of paper. So for example, I'm going to make one shot. The ball's going to go, and it says here I missed it. So over on our paper, I missed it. So the proportion I made is currently 0%. All right, so let's give this a try. Let's do our second shot. I'll take another shot. I missed that one too. So you'll do the same thing. It's another X in the 2 and it's still at 0%. Here's my third shot. Ooh, I finally hit one. I'm going to put a check mark in my here, and now it's 1 out of 3, so I'm at 33%. So we're just doing a cumulative to see how well I'm doing. So here we've got it. Shot number 4. It looks like I missed it, so put an X under 4, and I'm now at a 25% hitting. Not doing very well today. Shot number 5. I missed it again. So now I am at 20%. All right, so now what I'm going to do is our paper shows the next number is 10, so I'm going to tell this to take 5 shots in a row for me. And let's see our total percentage at that point. So here it goes, 2, 3, 4, 5, and now I have hit 3 out of 10, so my total percentage of hitting is 30%. Let's see how you're doing in keeping up with the numbers. So we're not going to worry about if I hit or miss because that was a whole bunch of them, but I'm at 30% right now. So now we want to go up to 15 and see how I'm doing. So that's another 5. I'm going to tell it to shoot. Here it goes. Oh, I'm up to 33% at 15. All right, 5 more. I'm at 35%. All right, well, let's tell it to do 10 now. Let's kind of amp this up and see what's going to happen. We're going to tell it to throw 10 free throws for me right now. Here we go. Oh my gosh, I was on a streak. I'm up to 40%. Let's do another 10. See how it's doing. Oh, that's not bad. That's probably better than I am in real life. At 40 throws, I'm at 45%. Here we go to 50. Oh, I'm all the way up to 50%. That is definitely better than I am in real life. 10 more. At 60, I'm at 50%. We'll just do this a couple more times to finish out our chart here. At 70, I'm at 50%. And then 10 more. All right, I finished out at 51%. All right, let's take a look here. So these are the numbers that you should have written in What do you think my true free throw percentage is? Just make a guess for number 2. Then I want you to sketch the graph that we have made, and I'll put that up. So I would pause the video and sketch the graph, and then we're going to answer some questions. All right, so this isn't perfect, but it gives you an idea that up in the very beginning there was nothing. I didn't get any shots hit until the third one, and then we're kind of bouncing up and down, and the further out we get, the smaller these changes are as we go along. All right, so my question to you is, what do you think my free throw percentage is? And let's see what the app said it was. If I show my free throw percentage, it showed it to be at 55%, it looks like. So 55%. Okay, so I'm going to draw that in. So as you notice, I started off and I was very bumpy, and as I go along, I'm approaching this line at 55%, and I'm getting closer and closer. So how could I make my guess more accurate, do you think? What do you think could happen? I could probably take more free throws. So according to the applet, I have a 55% chance of making a free throw. So let's talk about a little bit about these. How close were you here? That would be a good guess. I'm going to guess most of you guessed lower than 55% because of this very beginning information. So what is important about that is this beginning area. This is very unpredictable. So we're getting kind of a cumulative percent over time, because as I'm taking more and more shots, we're getting the percent over time. So this beginning part is going to be all jagged and very unpredictable. But when we get out here, notice how it's starting to smooth out and it's not quite as bumpy. So this area here is far more predictable. Okay, and remember, your green line here is my true free throw percentage. All right, so early short term is very unpredictable. As you get longer term out with more and more events under the same conditions, that's going to be a lot more predictable. Okay, so that's what we were saying with this take more free throws. If I keep taking them, you'll have a much better idea. But this idea of this long-term predictability is called the law of large numbers. Okay, so, and we said I had a 55% chance of a probability of making this free throw. So if I want to interpret this, so remember, this is a very long term where we can be predictable. So if Dr. H takes many free throws, so we want to take a whole bunch of them, not just a few, takes many free throws. About 55% of them will be made. So what's really important here is this whole many thing here. Not just a few, but you're talking very long-term probability here, not a short-term run. You know, you can flip a coin and you might get a whole bunch of heads in a row, which would feel unusual, but short term is very unpredictable. But as you toss that coin more and more and more and more, eventually it's going to start to flatten out and it's going to approach 50% heads, 50% tails. So you want a very long-term predictability. All right, so let's start summarizing this sum. So we have probability. Probability is the long-run relative frequency. It is always going to be a number between 0 and 1. 0 probability means it never ever happens. 1 probability means it happens every single time. And one thing you must always remember, short term is very unpredictable and your long term is much more predictable once that graph starts to smooth out. Now let's talk about the law of large numbers. So our law of large numbers says if we do something many, many times, the proportion of desired outcomes will approach its true probability. So any short term, we saw on that graph, there was a jagged up and down as the numbers bounced back and forth. But the further out we got and the more trials that we made and I took the shots many, many times, it started to even out and approach the true probability. So what I want you to do is I want you to pause the video, try to check your understanding on your own, and then come back and check your answers. All right, so let's see what you got. So if the outcome is impossible, it can never occur, that would be a probability of 0. So you can have lots of different examples. An example I have is rolling a 7 on one regular die. On one regular die. So a regular die has 6 sides. So the probability of rolling a 7 on a regular die is 0. It cannot happen. If we're talking about the bigger dice like they use in D&D, that would change. That would have different probabilities. But there isn't a 7 on a regular standard die. If the outcome is certain, it will occur on every trial. That means it happens every single time. The probability is 1. So using that same idea, rolling a 1 to either a 1 through 6, any of those on one die. On a standard die, the sides are 1 through 6, so that's what has to happen. It will happen every time. We won't get a different number because they're not there. So this outcome is very unlikely, but it will occur once in a while in a long sequence of trials. So that would be the 0.001 choice. So if we had, here's a good one. If you're guessing a number, from 1 to 1,000. So it doesn't happen very often, but it can happen. Sometimes when we watch Jeopardy at night, based off the title of the final Jeopardy, we try to guess the answer. Every once in a while, we're actually able to guess the answer. It's very exciting, but it doesn't happen very often. So that would be, I would say it's probably a 0.001. Okay, and then how about this scenario? This outcome will occur more often than not, but it does not occur almost every time. So let's see, if I had, let's give you a visual on this one. So if I had a wheel, and I'm going to break it up here into sections, and I'm going to have a blue section, and I'll have a red section. And then I'm going to make all the other sections green. Okay. It is not certain I will land on green, but it's more likely than not because there's, out of all of those sections, one is red and one is blue and everything else is green. So in this case, landing on green. It's more likely than not, but it's not certain. All right. How about in the Wheel of Fortune, there is a 1 in 9, which equals 11.1%. Notice there's no naked numbers. They showed where it came from. Probability of spinning bankrupt on any given spin. Interpret this probability. So after many, many spins, about 11.1 of them land on bankrupt. Okay, so in 9 consecutive spins on the Wheel of Fortune, none of the spins land on the bankrupt. The next contestant worries that he is more likely to land on bankrupt now because bankrupt is due. Explain why this is wrong. It doesn't matter what's already happened. The wheel has no memory whether it's spun a bankrupt or not. Every time somebody spins, there's an 11.1% probability of a bankrupt. And also remember, your probability is very unpredictable in the short run. So you can't say, oh, I bet this is what has to happen. The probability of that next spin is still 11.1%. Hopefully that was helpful. See you in class. That shot. Let me know if you have any questions. See you in class.